All right, so hi everyone. Very good evening to you all. Myself Ayush Tripathi, and welcome you all to this post-analysis discussion of the last weekly contest 204. So before starting the discussion, just let me know if I am audible. Write a quick +1 in the chat box, and also tell me how many problems you were able to solve. And all the four problems were really very nice, and each problem has a unique learning. So just write a quick +1 as a confirmation from your side, so that I can start the discussion. Tell me how many problem you were able to solve during the contest. Anyway, starting with the first problem, let me just share my screen. So today's problem were difficult. Not at all. Just try to pay attention and we'll discuss the solution for all the four problems. No worries, Chris. Just listen to my explanation. So this template seems good to me. Let me take the session off camera. So starting with the first problem, that is find the total pairs. So before starting the discussion, let me check if everything is fine.
Get the pen.
Okay, so here Arun is asking what is the approach for the third problem. Don't worry, we'll discuss the solution for the third problem as well. So starting with the first problem, find the total pairs. In this problem, given an array of integer ARR, the task is to find all pair of I comma j. Here I comma j is the index which meet the following condition. That is I and j must not be equal, and ARR of I minus ARR of j should be divisible by I minus j. And the third condition, which makes this problem very easy, I can say a cakewalk problem. So ARR of I minus ARR of j divided by I minus j should be equals to 1. So let's just quickly elaborate all the condition. So the very first condition which was there, I must not equals to j. I must not equals to j. Then the second condition, ARR of I minus ARR of j should be divisible by I minus j. That is mod with I minus j should be equals to 0. Right? This was the second condition. And the third condition, ARR of I minus ARR of j divided by I minus j, this should be equals to 1. Right? So now let's elaborate this third condition. So what I can say, I can just multiply this I minus j here on the right hand side. So I can say ARR of I minus ARR of j, this should be equals to I minus j, right? And now let's take both the term which has variable I on the left side, and we'll take both the term which has variable j on the right hand side. So I can say ARR of I minus I, and this should be equals to ARR of J minus J, right? And this is the crux of the problem. Now you need to satisfy this condition. And this is a very standard equation, and we can solve this. We can solve this equation. We can count the pair of I comma j with the help of a hash map. So we have been given an array ARR. So let's call this array ARR. So index 0, then index 1, index 2, index 3, then a current index I, then index I plus 1, and up to index n minus 1. So now we are going to find the contribution of each and every index, how many pairs it will form, right? So this is a very standard technique, which is a contribution technique. That is, we find the contribution of each and every index, and if I somehow get the contribution of each and every index, then I can add them together. That will be my total answer. So contribution technique simply says that find the contribution of each and every index and then add them together. So we are going to use a hash map, right? So that is, I will just simply build the hash map in a progressive order. That is, before coming to the index I have information for all the indexes from 0 to I minus 1. And before reaching to index I plus 1, I will simply insert this index I in my hash map, right? So for example, the current value is ARR of I. So we know the index, we know the element value. So I just simply find their difference, that is ARR of I minus I. So this is the value which I am looking for. So now I'm going to just simply check how many values are there previously which are having which is having value less than, which is having index less than I and having this value. So basically this is the value that we are looking for. So it might be possible when this value is at index 3 and it may be at index 1, and let's say it is also at index 0. So how many pairs we would have? We would have these many pairs. So this is the information that we need to keep track. So let's do a dry run, then it would be more clear to you. So what I can say, I can dry run over this example. So the first element is 1, then a 6, 0, then 2, 3, 8. So initializing the answer with 0. And initially my hash map is empty. So let me also write the index value. So we simply iterate over all the index from 0 to n minus 1. So I iterate over all the index from 0 to n minus 1. And then for every index, the difference is ARR of I minus ARR of J. Sorry, ARR of I minus I. This is the difference that we are looking for. So I just simply ask my hash map, tell me how many indexes will which are having value less than I and having this value difference, and I will increment my answer by that factor, right? So starting with the index 0, I is equals to 0. So that the value of a difference, it is equals to 1 minus 0, which is equals to 1. So initially my hash map is empty, so we would not have any such value. And then before moving to the next answer, before moving to the next index, I'm going to hash this value difference. It might be helpful in future. So let's say the name of my hash map, it is a map only, I can say. So map of 1 plus plus. Previously it was 0 and now it is equals to 1. That is, we got one index for which this is the value, for which we have this value. this difference, right? So this is the first step. First step is to find the difference. Then second step is to find the answer, or I can say update the answer. And the third step is to hash this value. So I can say map of difference plus 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 equals to 1. Increment the frequency. Now coming to index 1. So I is equals to 1. So in that case, what will be the difference? So 6 minus 1, which is equals to 5. And we do not have any entry of a 5 in my hash map. So do not increment the answer. Then add this in your hash map. Previously it was 0 and now it is equals to 1. Now coming to next index, I is equals to 2. So in this case, the difference would be 0 minus 2, which is equals to minus 2. And we do not have any such entry. So do not increment the answer. Add this in a hash map. It might be helpful in future. Coming to next index, I is equals to 3. So in this case, the difference is 2 minus 3, which is equals to minus 1. So we do not have any entry of a minus 1. So we do not increment the answer. And then we simply hash this value. That is, we got one index for which the difference is minus 1. Now coming to I is equals to 4. So the difference is 3 minus 4, which is equals to minus 1, right? And now we are going to check how many values we have, how many indexes we have which has the value minus 1. So there is exactly one index, right? It's a frequency of minus 1. It is equals to 1. That is exactly one index we have which has the difference minus 1. And it is index 3 actually. So this index 3. So index 3 and index 4 both will form a pair. So in this case, let's find the value of AR of I minus AR of j and divided by I minus j. So here in this case, it is a 3 minus 2 and 4 minus 3, which is equals to 1 divided by 1, and it is equals to 1. So it satisfies the condition, and also I can say both the numbers are divisible. That is, numerator is divisible by denominator. Cool. So we have this pair. Now one thing, if you have noticed one thing, we need to count the number of pairs of I comma j, right? So I can consider this a 3 comma 4 as one pair. Then another pair that we would have is a 4 comma 3. That's why we multiply our final answer by 2. That is a I comma j. It has one contribution in my answer, and j comma I, it has another contribution in my answer. So that's why we multiply our final answer by 2. After this for loop, multiply your answer by 2. Right? And now we are going to increment the frequency of minus 1. Previously it was 1. Now it is equals to 2. Right? Now coming to index 5. So here in this case, the difference is 8 minus 5, which is equals to 3. And we do not have any occurrence of 3 in my hash map. So we do not increment my answer. So my answer is incremented by only 1. And then I will multiply my final answer by 2. So answer is equals to 1 multiplied by 2, which is equals to 2. And then I will just simply return this answer 2. Now let's see an expected output. And it is also 2. Cool. So I hope now this is clear to everyone. And here we have implementation. This is the method that you need to complete with the given array. Taken the size of the array, initializing the answer with 0, iterate over all the index, and this is basically the difference, or I can say the key and if it is present in my hash map, then I will increment my answer by the value of that key, and then simply hash the current difference and multiply your answer by 2. The time complexity is order of n. Since we are using a hash map. Now coming to the next problem, string operation. So given a string s, and you need to traverse it from the left to right, that is from index 0 to index n minus 1. And for each character which is at index I, if s of I appear before and after index I, then you have to delete the immediate previous occurrence and the immediate next occurrence of the character s of I. And after each approach, you need to update the string and restart the traverser, right? And repeat the process until no more such operation can be performed. So basically, I need to perform all the operation, and we have to return the final modified string. Now, if you follow the brute force approach, then it will take order of n square time, which will definitely give you time limit exceed because the value of n can be up to 10 power 5. So n square solution is not feasible. We have to do something better. Now before this, I can explain you this example. So after the first operation, we simply select this occurrence of B, and we have the occurrence of B. Okay, what I can do? Yes, I can select this occurrence of B, and we have a B on the left hand side, and then we also have a character B on the right hand side, and we delete both the immediate left and immediate right character. So after the first operation, your resultant updated string would be A, then B, then B, A, and B. So this will be your updated string. Now we perform the second operation. Again, select the occurrence of B, this occurrence of B, and delete the occurrence of B which is on its left, and delete one occurrence of B which is on its right, immediate occurrences. Now after the second operation, the updated string would be A, B, A, and yes, we would have this string. And now I cannot perform any more operation because for this character A, we do not have any occurrence of A on a left hand side. For this character B, we do not have any occurrence of B either on a left or on a right. Then for this occurrence of A, we do not have any occurrence of A on a right hand side. So that's why we cannot perform any other operation, and this will be my final answer: A, B, and A, which is same as the expected output. And here we have the explanation. Now the thing is how we can solve this problem in order of n time or n log of n time. So let us draw some observation. So the very first thing, let's say the current character is s of I. So what we are looking for? So So before s of I, that is before index I, we are looking for the character which has the same value, right? So let's say we have a three character before s of I, and the second character has value s of I, the same value. And on the right hand side we would have some character. Let's say we have four character, and the last second character has the value s of I. So in that case, what you need to do? You need to delete these character. You need to delete these occurrences of the character, the immediate occurrence. So the very first thing we need to observe, that is, we can consider the character which is of the same type. We don't need to worry about what we have at here. We are not interested to know. We are not interested to know what we have at here. We are not interested to know what we have at here. We are not interested to know what we have at here. So what I'm trying to say, each time I can process the character which has the same value. Now let's see how we can process the character. So for the sake of simplicity, I'm going to process each and every character. So for example, let's say you have a string s with the value a, b, then let's say d, again b, then a, then let's say c, and d. So what I'm going to do, I'm going to treat each and every character, uh, I'm going to process each and every character individually. So for example, first in a first operation, or I can say in a single go, I'm going to process the character a, that is how many occurrences and what are their position in my resulting string. Then we are going to process all the occurrences of a character b, because the individual character b is not bothered by any other character. Then I'm going to process all the occurrences of character c, and then I'm going to process all the occurrences of a character d. So in this way we can perform the operation and find the resultant string. So to process all the indexes of a character A, we need to know what are the indexes we have. So this is index 0, then index 1, index 2, 3, 4, 5, and 6. So what I'm going to do, I'm going to create a hash map, or you can use some other data structure to store the indexes of a particular character. Right? That is a create a map, or I can say hash map. Both will pass all the test cases. So the key here is character, and the value here would be array. So in case if you are using Java, then it would be a list, but I am going to implement this in a C++, so that's why it is a vector. And yeah, then we would have some name. So let's call this as MP. So MP of A will store all the indexes of character A. So what are the indexes of character A we have? So index 0 and index 4, right? Let me add some other occurrences of A. So 7 and 8. So then value 7 and value 8. Then indexes of a character B. So the character B is present at index 1 and it is also present at index 3. Then character C has only one occurrence, which is at index 5. Then character D has only two occurrence, at index 2 and at index 6. Right? So in a single go, in the first iteration, I'm going to process all the occurrences of character A. That is, will find how many occurrences of A we would have in the final string, right? And then in the next go, I will process all the occurrences of character B, and in this way we find the answer. Cool. Now without losing a generality, let's say all the indexes we would have, let's say all the indexes have the same character without losing a generality. And this is just for explanation purpose. So what I am trying to say, so let's say we have a string A which has all the occurrence of character A. All right. or I can take some other character, but let's say character A. But you know that is the occurrences of A, it is basically a subsequence. So let's consider that we are going to process this subsequence, and it is of a odd length. So let's consider the case 1 when it is having the odd length, or I can break down into a 3 cases. So case 3, case 1, when the length of the subsequence, let's call this as n. So n is basically the length of the subsequence, or I can say the length of a string s. So the very first case, when the value of n is less than or equals to 2. So what will be your answer in that case? So in that case, you cannot perform any operation, right? In that case, you cannot perform any operation. So what I can say here, let's say n is equals to 2. That is, you have a string L with the 2 occurrences of A. So in that case, you cannot perform any operation. So in your answer, you have to append both the character. So in your answer, just simply append both the occurrences of this character. So answer plus equals to this entire string. Cool. Now let's consider the case 2, when the value of n is greater than 2, that is equals to or greater than 3, and let's say n is odd. So n mod 2, it is equals to 1. Now let's say the value of n, it is equals to 5, or I can say 7. Take some bigger value, and let's say we have a character s, a. So let me also write the index. So index is 0, 1, 2, 3, 4, 5, 6. Cool. So in the first operation, it is clearly mentioned in the problem statement. That is, we always start from left to right. Right. So that's why in the first operation we are going to delete these two occurrences. The character which is at index 0 and the character which is at index 2. We are going to delete these two characters. Then in the second operation, we delete these two characters. The character which is at index 1 and the character which is at index 3. We simply select this character which is at index 3, and then we delete the character which is on its immediate left, and we delete the character which is on its immediate right. So index 1 and index 4 after the first operation. Then in the third operation, we are going to select the index 5. We simply select the index 5, and then we delete the character which is at index 3 and the character which is at index 6. So what I'm trying to say, you are only left with the last second occurrence of the character. So in my answer, what I will add? I will simply add the last second occurrence of the character. So answer plus equals to s of n minus 1. S of n minus 1. Or I can say, I can write it here. In the final string, we are only left with the last second occurrence. So last second occurrence of the character. Now coming to the case when we have even number of character. So that will be my case 3. N mod 2, it is equals to 0. So let's say n is equals to 8. So we would have 8 occurrences of character A, which could be at any position. It is basically the subsequence. So index 0, then 1, 2, 3, 4, 5, 6, and 7. So in the first operation, we are going to delete the character which is at index 0 and the character which is at index 2. So we are going to delete these two characters. Right? We select I is equals to 1, and it has a character. It has the same character on its left and the same character on its right. Now in the next operation, we simply select I is equals to 3, and then we delete the character which is at index 1 and the character which is at index 3, sorry, index 4. Then in the third operation, we are going to select I is equals to 5, and the immediate left character, it is 3, and the immediate right character, it is at index 6. So we are going to simply delete the character which is at index 3 and the character which is at index 6. Cool. And now what we are left with? Now we are left with the character which is at index 5 and the character which is at index 7. And these two characters which we would have in my final string. So that's why I can say answer plus equals to s of 5, which is n minus 3, n minus 3, and answer plus equals to s of n minus 1. So basically the last third character. So in your final string, what you would have, you would have the last third character, or I can say the last third occurrence of the character, and the last occurrence of the character, n minus 1 and n minus 3. So yeah, that's the complete solution. Just simply iterate over the indexes of the particular character, and if the number of indexes, or I can say the size of a subsequence, is less than or equals to 2, simply append both the character in your answer. Append all the character in your answer. If it is odd, then you are left with only one character of that particular type in your final string, and that character would be the last second occurrence. Then the third case, if the frequency is 0, sorry, if the subsequence length, or I can say the frequency of the character, is even, then you are left with the last third character and the last character of the particular type. So this is the complete solution. Now you might have a different implementation, or what I would suggest, just pause the video here and go and try to implement it by your own, and then come back and see my implementation. So here what I'm going to do, I'm going to first find the frequency of all the character in my unordered map MP, and then we are going to iterate over all the character from index n-1 to index 0. This is my current character, and if the current character has overall frequency less than or equals to 0, so that character will be in my answer, right? And then here I'm going to check if the frequency of a character is odd, if the total frequency of the character is odd, and if it is the second last character. So we have another hash map which I'm going to use just to simply check which frequency it is. So if it is the second character, that is, if it is the second last character, then we are going to simply append this in my answer. Otherwise, here I'm going to simply check if the frequency is even, and if it is the last character, or if it is the second last character. Sorry, if it is the last character, or if it is the third last character, then in that case I will simply append the character in my answer. And since we traverse from right to left, so that's why we need to reverse the answer, and finally I will return this reversed answer. And the time complexity is order of n only, since we have used the unordered map. So that's the complete solution. You might have some different implementation, that's totally fine, but this was the key observation. Now coming to the third problem, total absolute character difference. So you are given two string s and t, and compute the total absolute character difference between each substring of S and every substring of T that which has the same length. So basically, if you consider the substring of length, let's say 3, then you have to consider all the substring of length 3 in the string T, right? And the absolute character difference between two string S1 and S2, it is basically the sum of absolute difference at each index. Absolute difference between the character at each index. So the differences between the sky values definitely, and the string contains only lowercase English alphabet. So let's say string A, it is equals to AB, and string T, it is equals to AB and C. So let's consider the substring of length 1. So what are the substring of length 1 we have in a string A? So what I can say, S1 is equals to substring of length A, and then let's consider the another substring S2, which is equals to B. So this is the two string of length 1. Cool. And how many substring we have of length 2 of length 1 in a string T? So in a string T, how many substring we have? So let's call this as a T1. So it is A, then a T2, it is equals to B, and then T3, it is equals to C. Right? So we need to consider all the substring of length 1. And for the same, we need to consider all the substring of length 1. That is, in both the cases, we have the same thing. Let's consider all the substring of length 2. So substring of length 2. So how many substring we have? So we have only one substring. Let's call this as S3, and it is AB. And corresponding to this substring of length 2, how many substring we have in a string T? So let's call this as a T4. So it is equals to AB. So in this case, the absolute difference would be 0, because in both has the same character. Then T5, and it is equals to B and C. This is the this is the another substring of length 2. So in this way we can find the answer. Now the thing is how we can solve this problem efficiently. So let's say n is the length of a string S and m is the length of a string T. Now let's analyze the constraint. So the value of n can be up to 50, and the value of m can be up to 2 into 10 power 6. So as per the constraint, the value of n can be up to 50 only, and the value of m can be up to 2 into 10 power 5. So it is actually 2 into 10 power 6, which is not an issue for me. So the idea here is to generate all the substring of length, all the substring of a string S, because it has a length less than or equal to 50. So yes, it is feasible. It is feasible to generate all the substring. So this will be my first step. Generate all substring of string s. Then for every substring, find the contribution. Find the contribution of a particular substring. And to find the contribution, we are going to iterate over all the character. We are going to iterate over all the character of a string t, and we simply use the sliding window approach. So iterate over all the window of a string t. So that's my general idea. To iterate over all the window of a string t, it would take order of m time, and the number of substrings that we would have, it is of order n square. So the time complexity would be n square, the number of substrings, multiplied by the time complexity of this sliding window approach, which is order of m. So this is a feasible solution, and it will pass all the test cases. That would somewhere around a 10 power 8, which is fine. Cool. Now let's say the current substring, let's say it is equals to a, b, and c, and let's say the current substring, the entire string t, it is equals to a, b, c, d, and e, and let's also say f. So here the length of the string, let's call this as a lowercase n. The length of the substring of s, it is equals to abc, which is equals to 3. So the length here is 3, right? And how many substring we would have of length 3 in my string t? So substring of length 3. How many substring we have? ABC, and then we have a BCD, then we have a CD and E, and the last substring of length 3, it is D, E, and F. Cool, right? And let's find the contribution of each and every character of the string S. That is which is nothing but the substring of the original string S. So let's find the contribution of each and every index. So index 0, 1, and 2. So let's find the contribution of index S of 0. So this S of 0, it is equals to character A, and it is being mapped with the character A. So it is going to be mapped with the character T of 0, right? Because if I consider the substring of length 3, so this is the first character of the first substring, then first character of the second substring, then first character of the third substring, and finally the fourth substring, right? So which is nothing but a T of 0, then T of 1, T of 2, and finally T of 3. So index 0, index 1, index 2, index 3, index 4, and index 5. Right? So the first 4 character. Now S of 1. Find the contribution of S of 1. So S of 1, it is equals to character B. And now this S of 1 being mapped with T of 1, right? T of 1, then T of 2, then T of 3, and finally T of 4. T of 4. Which is the second character of the first substring, then second character of the third substring, then fourth substring, second character, and finally the second character of the fourth substring. Now let's consider the last character, S of 2, it is equals to C. And now this character being mapped with the T of 2, right? Then T of 3, T of 4, and T of 5. And we can implement the solution in order of m time. We can implement the solution with the help of a sliding window in order of m time. But let me explain you. So the current character, the last character is S of 2, right? And the last character of the first substring of a t, which is having length 3. Then second substring of length 3, the last character, then last character of the third substring of length 3, and the fourth substring of length 3, and its last character. So t of 2, then t of 3, t of 4, and t of 5. And we can implement this idea with the help of a sliding window approach. So now what I would suggest, just pause the video and try it by yourself, and then again come back and watch the implementation. Now let me explain you with this example only. So you might have some different set of implementation, which is totally fine, but the idea here is to use the sliding window approach only. So I'm going to explain with the same example, A, B, and C. Now string T, A, B, C, D, E, and F. Now the value of n, it is equals to 3, and the value of m, which is a global, and it is equals to 6. So index 0, index 1, index 2, index 3, index 4, and index 5. Then again index 0, 1, and 2. So what I did in my implementation, I have used a frequency array. So frequency array of a size 26, and this frequency array will simply store the frequency of all the character of a string t. So frequency array of size 26, because all the characters are lowercase only, and it will simply store frequency of all the characters of a string t. Cool. And then from here, first I'm going to simply subtract the frequency of these character. That is, remove the frequency of these character in my frequency array. So after the first step, this will be my first step is to calculate the frequency of each character of a string t. So the frequency of A, it is equals to 1. The frequency of B, it is also equals to 1. And basically all the character has frequency 1. So here I have written A, B, and C, but you know all that is it is their ordinal value. This is very basic thing. I'm not going to explain you this thing. That is index 0 is being mapped with the character A, index 1 is being mapped with the character B, and so on. Then the frequency of character E, it is 1. Then the frequency of character F, it is also 1. Cool. Then after this, I'm going to delete the last n character from this T. Right? This is basically the last 3 character. So this will be my second step. So the first step is to calculate the frequency of each character of a string T. So let me write side by side, then it would be more clear to you. So delete last n character of a string T from the frequency array. So for example, I just simply decrement the frequency of character F, change it to 0. Frequency of character E, change it to 0. Frequency of character D, change it to 0. Right? And then after this, now coming to the most important part, after this we simply iterate, we simply iterate from left to right. After this I can just simply iterate from here and up to 0, up to index 0. And for every index I'm going to use another variable. Let's call this as ind, and initializing the value of ind with 0. So this ind is currently pointing at index 0, since we are going to find the contribution of index 0. Cool. And after this I'm going to simply iterate from, I can say index m minus n, right? In this case the value of m minus n, it is equals to 6 minus 3, which is equals to 3, right? Basically the last window, starting of a last window. So this index 3 is the last window, starting index of the last window of length 3. So that's why we start from here, right? And the very first thing, we simply add, we simply add the character. We simply add the character which is at this index. So the character which we have, it is d. So we simply increment the frequency of d. So simply increment the frequency of d. This is my way of implementation. You might have some different way of implementation. It is totally up to you. But here I am going to explain my solution. So we simply add the d here, and then what I will do, I will simply iterate over all the 26 character. We simply iterate over all the 26 character, and whichever character we have at this position, we are going to calculate its contribution. Right? That is at this point of time, I'm going to calculate the contribution of. So it is basically the sub step. The sub step is to calculate the contribution of index s of ind. So find contribution of s of ind. We simply find the contribution of s of ind. And in s of ind, what we have? In s of ind, what we have? In s of ind, we have a character a. So at this point, s of ind, it is equals to character a, or I can say s of 0. Let me write it in this way, s of 0. So this is my s of 0, and what we have in this s of 0. So in my frequency array, what we have? My frequency array, it has all the frequency of these character. It has the frequency, it has stored the frequency of this substring from index 0 to index 3. So in this way, we find the contribution of s of 0, and then we increment the value of ind. So we simply increment the value of ind. We simply increment the value of ind. So ind plus plus after finding the contribution. So ind plus plus, and do not forget to delete the frequency of a character s of ind. So before incrementing the value of ind, s of ind, delete the frequency. So delete the frequency of t of ind minus minus. So delete the frequency of this character, and then simply increment the value of ind. So basically index 0, s of 0 being simply mapped with the all these character which is highlighted by this magenta color. And then what I'm going to do, I'm going to simply delete this character which is at index 0, and in the next iteration we simply add this character. In the next iteration we are pointing to index 4, and we simply add this this index 4 in my frequency. So we simply decrement it by 0, right? And then we simply increment the frequency of t of j. So t of j plus plus, right? That is just simply enable the character which is at index 4. So at index 4 we have a character e. So simply increment its frequency. Previously it was 0. It has been removed from the map, and now I again inserted in the map, right? And then we simply find the contribution of index 1. So s of 1. So simply find the contribution of s of 1. So now S of 1 will simply map with these four characters, T of 1, T of 2, T of 3, and T of 4. Just simply look at here. T of 1, T of 2, T of 3, and T of 4. Right? So in this way, we find the contribution of S of 1. And then the idea here is to delete the character which is at index 1 from the frequency. So simply decrement it by 1. Now it is 0. And increment the value of IND. So now IND is pointing to index 2. Find the contribution of S of 2. And to find the contribution of S of 2, we must have to add this character which is at index 5. So we simply add this character which is at index 5. And now this is the range which we have in my frequency array. So simply enable this character and then find the contribution. So basically S of 0 was mapped with the T of 0, T of 1, then T of 2, and T of 3, right? Then S of 1, it was mapped with the T of 1, T of 2, T of 3, and T of 4. Then S of 2 was being mapped with the T of 2, T of 3, T of 4, and T of 5. So yeah, this was my complete solution, and it will take order of M time only. So order of M time with the help of a sliding window approach. So it is actually order of M multiplied by 26, because for every to find the contribution of S of 0 or S of 1, we need to iterate over all the character. So this is the way how we can find the contribution of a current substring of a string S. Now I hope it is clear to everyone. Coming to the implementation. So this is the method that you need to complete. Total difference. So first I am having this helper method, generate substring. So it generate all the substring of a string S. So this is my result, which is a vector of a string. Iterate over all the substring and then simply insert it in the vector of list, in a vector of a string, and finally return this string. Cool. And after this, calculate the frequency of each character of a string T, initializing the answer with 0, iterate over all the substring, and for every substring, I will call the helper method solve. And the solve helper method will simply return me the contribution of a particular substring. Now this is my n, and basically the length of the current substring, then the length of the string T. Then this is my first step. Delete last m character. Delete last n character of a string T. Then this is my IND initializing with 0, finding the contribution of index 0 of a current substring, then index 1 of a current substring, and so on. This is my temporary answer. The first step is to include the character, and the second step is to find the answer. Iterate over all the 26 character, and this is the contribution of S of IND. Cool. And then finally, what I can say, yeah, remove this character. Remove this character from the frequency array and increment the value of IND to find the contribution of a next index, and then simply return this temporary answer. So in this way, we can find the contribution of a current substring. So if it is sound confusing, then you can take a multiple pause and rewatch the recording of this session. Now coming to the last problem, operations to make palindrome subarray. So this was really very interesting problem and very intuitive idea. So you are given an integer array ARR. Your task is to consider every subarray of ARR individually and determine the minimum number of operations required to convert each subarray into a palindromic subsequence, or I can say palindromic sequence. In one operation, you can change any one element to any other element, and the operations are local. That is, it will not affect the original array. For a particular substring, whatever the changes you will make, it will only for that substring. And once you find its contribution, you have to again return back to the original substring, or I can say subarray. So operations are local to the subarray and do not affect the original array or any other subarray. And each subarray is treated independently. And here we have the definition of a palindrome, which we all know. Then each number in an array appears at most 100 times. So this was the main observation. So let's see how we can solve this problem. So let's say we have a array A and it has all the distinct elements. So for example, let's say we have the element 1, 5, let's say 2, 4, and let's say 10. So let's say we have all the distinct element. Here the value of n, it is equals to 5, the length of the array. Now what I can do, I can iterate over all the subarray of a particular length. So let's say how many subarray we have of length 1. So how many subarray we have of length 1? So number of subarrays of length 1. It is equals to 5. It is simply equals to 5. These many subarray we have of length 1. Now let's say how many subarray we have of length 2. So it is equals to 4, right? The first subarray of length 2, then a second subarray, then a third subarray, and finally the fourth subarray of length 2. Then let's see how many subarray we have of length 3. So it is 3. It is 3. So first subarray, then a second subarray, and finally the third subarray of length 3. So we have a 3 subarray of length 3. Then how many subarray we have of length 4? It is basically 2. We have a 2 subarray of length 4. And how many subarray we have of length 5? Exactly 1. Right? So the number of subarray we have of a length I, it is equals to n minus I plus 1. So this is the first observation. Number of subarray of length I, it is equals to n minus I plus 1. And here I assume that all the elements are distinct. So for a particular subarray, how many minimum operation we required? Let's find that value. So let's consider the subarray. The subarray of length, I can say of length 4. Let's say 5, 2, 4, and 10. So to make this subarray as a palindrome, the first element must be equal to the last one. The first element must be equal to the last one, right? And the second element must be equal to the second last element, and so on. So how many operations do we exactly require? So let's say k is the length of the subarray. So let's say k is nothing but the length of the subarray, and it is equals to 4. So the number of operations that I required. So the number of operations which I required it is exactly k by 2, and we have to take its floor value. It might be possible when the value of k is odd, so in that case we need to take the floor value. For example, let's say subarray is of odd length, or I can say length of 5. So only one subarray. So how many operations do we require? So the number of operations that we required, it is equals to it is equals to 5 divided by 2, and take the floor value, it is equals to 2. We only require 2 operations to make the subarray palindrome. Just simply change this value with a 10 and change this value with 4. Now the subarray is a palindrome. So k by 2 operations we require, right? So let's assume all the elements are distinct, all the elements are unique. So the number of operations that we require in total, I can say initializing the total with 0, and then we iterate over all the possible length. So length is equals to 1, and it goes till n. So how many subarrays are there of a particular length? So the number of subarrays that we would have, it is equals to n minus length n plus 1. These many subarray we have of a particular length. And how many operation each subarray required? So the number of operation each subarray required, it is equals to length divided by 2, and take the floor value. Now I will just simply increment my answer by count multiplied by the number of operation, the number of subarray we have, and the number of operation each subarray required, right? So this will be my total answer. But the thing is, we can save some element. We can save some operation if the values are equal. We can save some operation if the values are equal. Now let's see how we can save some operation. So the value of total, let me write this in a layman language. So the total number of operations that we required if all the subarray are distinct. So it is equals to summation of length from 1 to n, and n minus length plus 1 multiplied by length by 2. So this will be my total answer when all the elements are distinct. But as we all know, we can save some operation if the elements are having asymmetry. So we are going to save some operation if both the elements are same. So in that case, I don't have to perform any operation. So for example, let's say the current array we have, it has some value. Then let's say we have a value 2 here. Then let's say we have a value, some other value, and let's say another occurrence of 2. And let's say then we have another occurrence of 2, and let's say another occurrence of 2. So now let's consider this example. Let me also write the index. So index 0, index 1, index 2, index 3, index 4, 5. Then 6, 7, 8, and 9. So we do this thing for all the elements. So at this point of time, we are going to process all the occurrence of element 2. Then in the next iteration, we process some other occurrence of all the occurrence of some other element. So now here we can save some operation. For example, let's consider the case when you have taken this subarray. So if you have considered this subarray, then in that case you don't have to perform any operation, right? Because the first element is equal to the last one. So we can save some operation here. Here we don't have to perform any, we don't have to waste any operation. Now the thing is how many operation we can save. So for this thing, let's first store the index of all the occurrences of 2. So again, I'm going to use a map or a hash map. The key here is element value, and we would have a corresponding vector of indexes. Let's call this as MP. So MP of 2. MP of 2 will simply store all the occurrences, all the indexes at which we have 2. So at index 2 we have 2, then index 5, then at index 8, and at index 9. So how many operation we can save in total? So let's forget all the other occurrences of 2. And at this point of time, let's consider these two occurrences of 2. Let's consider the occurrence of 2 which is at index 2 and the occurrence of 2 which is at index 5. So how many operations we can save? So the very first observation, when we consider these two subarray, so here we don't have to perform any operation, right? And let's say you have considered the subarray from 1 to 6. So if you have considered the subarray from 1 to 6, then again you don't have to perform any operation, because these two indexes are forming a symmetry in a palindromic subarray, so you don't have to perform any operation. Now let's say you consider the subarray. If you consider the subarray from 0 to 7, then again index 2 and index 5 will form a palindrome, will form a symmetry, and you don't have to perform any operation, right? So you can save one operation. So I will simply decrement my answer. I will simply decrement my answer by 3. That is, 3 subarrays are there for which I don't have to perform any operation, right? And if I write the formula, let's call this as let's call this as index I. Let's call this as index I, and let's call this as index j. So the number of subarray which we would have, and for which we do not have to perform the operation, and basically this I and j is having the symmetry, it is equals to minimum of I plus 1 because of a zero based indexing, and n minus j. So in this case it is equals to minimum of a 3 comma 5, which is equals to 3. That is, we would have a 3 subarray which has this symmetry. So I will just simply decrement my answer by this value. And yes, this is the complete solution. Once you have this formula, you can just simply decrement this value. Decrement the value of total by this factor. So in more generic way, I can say total minus equals to this value, right? And what will be the time complexity? So we'll come to this very soon, but let me first show you the implementation. So implementation is very small and very pretty and beautiful implementation. So initializing the sum, that is nothing but my total. So this is my total variable, and this is my map. I iterate over all the element, and just simply push the current index corresponding to the key current value, and just simply calculate the value of a total, which we all know that is equals to n minus I, and multiplied by I plus 1 divided by 2. This will be the value of total. And then initializing the answer with 0, I iterate over all the unique value, and for every unique value, this is my index I, and this is my index j, right? So p of I is the basically the index value, and this p of j is another index value. So simply add this value in your answer. So basically here this is not the solution which I have explained, or what I can do. Let me just implement it here only. So let me just try to implement it, or what I can do, I can just okay, let it be here. So initializing the answer with 0, or I can say total. Then value of total. So length is equals to 1, the length of the subarray, and the length less than or equals to n, then length plus plus. Then how many subarrays we could have of a particular length? So it is equals to n minus length plus 1. These many subarray we can have. and the number of operations that are required, it is equals to length divided by 2. So then total plus equals to count multiplied by number of operation. And let me just change one integer to a long just to avoid the overflow condition. And then what I can say, I can use a map to store the indexes. So integer, and then value will be vector mp, iterate over all the indexes from 0 to n, and here n is nothing but the length of the array. So arr dot size, then mp of arr of I dot pushback I, then iterate over all the unique value. So what I can say, auto it in my mp, here the value is it dot first and the corresponding vector of indexes. So it is equals to it dot second. Then iterate over all these indexes. So what I can say, let's say it is k1 and k2. So from k1 is equals to 0, then k1 less than or equals to the size of indices. So indices dot size, then k1 plus plus, then value of k2, it is equals to k1 plus 1, because basically we need to consider all the possible pair. So that would be k1 plus 1, then k2 is less than indices dot size, then k2 plus plus. So index I, it is equals to indices of k1, and index j, it is equals to indices of k2. And then I will just simply decrement my answer, which is nothing but the total by minimum of I plus 1 and comma n minus j. Cool. So I don't need this bracket, and let me just change the data type to a long just to avoid overflow condition. And finally what I can do, I can return this answer. So hope it will work fine. So actually it is total. So there are some typo error. So it is total, and I need to declare the value of n at here. So it is same as the expected output. And yes, successfully submitted. So this is the complete solution. And what about the time complexity? So the time complexity is number of unique element that we would have and multiplied by the indexes at which we would have the unique element. So the time complexity would be number of unique element. And it is clearly mentioned in the problem statement that each number in the array appear at most 100 times. So in the worst case, how many unique element we would have? It is the size of the array, which is 10 power 5, and the at most we would have the same element 100 times. So the number of unique element that we would have, it is 10 power 5. So let's call this as un. It is 10 power 5 divided by 100, which is equals to 10 power 3. So these many unique element we could have, and the maximum occurrence of a unique element, it is 100. So the overall time complexity would be 10 power 3 multiplied by 100 and again multiplied by 100, which is equals to 10 power 7, and it will pass all the test cases because it is having quadratic time complexity. These two for loop will have the quadratic time complexity, and the size of this indices array would not exceed 100. So yeah, that's the complete solution for all the four problems of last weekly contest. Hope you have enjoyed the contest and learned something new. Thank you everyone. Make sure to write your feedback in the comment box, and do let me know if you have any, if you required any further explanation. We'll discuss your approach in the comment box. So thank you everyone for watching this video, and have a good day. Good night.